We look into the first variant of product mix problem in Python with input material capacity and market constraint imposed on demand. Pulp and Pandas packages on operations research solver and data manipulation in Python are loaded. Along with the packages, data is also loaded. The problem consists of two raw materials and two end products, exterior and interior paint. These are represented as RM and prod lists. The demdiff parameter defines the difference in demand between interior and exterior paint. This is true for correlated demand between products. Raw material requirement for the two products is stored in RMREAT list. The raw material capacity, profit and maximum demand of end products are stored in RMCAP, profit and maxdim lists. An enumerated list from prod is defined with raw materials and end products for linear programming model. For easing data slicing in the model, we employ a data frame for profit, maximum demand, raw material requirement and raw material capacity under profit def, max den def, RMRUCT and RMCAP def. We create a class RedDemix. Initialize the class with a method and feed the data and data frames to it instantly. Next, we define the problem self.prob for maximizing the profit. Next we declare continuous variables self.varList for product produced from the list self.prod. After declaring the variables, objective function is defined. The objective function is prepared by summing up profit multiplied with amount produced self.varList for all products. The first constraint is for each raw material amount self.RMRUCTDIF multiplied with amount produced self.varList for all products, which should be less than or equal to capacity self.RMCAPDIF. The second constraint is for each end product produced self.varList, which should be less than or equal to demand imposed for each end product by market self.maxDendif. The third constraint defines the market constraint for demand difference between internal paint product and external paint product must not exceed the demand amount self.demdif, which in this case is 1 unit. The formulated problem is then invoked for solving with solve method. Please note we also write a .lp file, which is a good way of checking accuracy of model with data. Other methods are for getting the status, objective value and variables value as usual. Finally, the formulated model is solved to analyze the result. The optimal product mix requires producing 3 units of external paint and 1.5 unit of internal paint, which yields profit of $21. The code for the problem in this tutorial and previous tutorial are shared publicly on GitHub. The links are under the respective videos. Thank you for watching the video and please subscribe to the channel.